Good afternoon, Mr. Xie. Today, my group and I will be talking about scanning electron microscope. My group comprises of me, Darren,
Go!
俊杰、
俊造、
Kevin、
and Xingwing. I'll be talking about SEM. So what exactly is SEM? It's a type of electron microscope where a focused beam of electron is used to scan a sample instead of a light ray, which is a light source. And many people will be asking what are the advantages. Well, one of them is a higher magnification and resolution as compared to light microscope. More about what is inside the SEM. Actually, this is a simplified version of the SEM. As you can see, an electron beam gun will emit the strong electron beam onto the condenser and aperture. It will pass through the condenser and aperture before hitting onto the specimen to show the surface morphology of the specimen structure. Let's take a look at what's happening on the surface structure of the specimen.
Go.
On the surface specimen, there are three different types of electron that will be reflected or emitted. The first electron is secondary electron, followed by the backscatter electron and the X-ray. Why is this so? This is due to the different depth penetration of the three different electrons. In order to catch the three different electrons, various specific detectors will be used. The different data collected will be translated into images, which will help us into finding different applications, which will be further elaborated by my teammate Jun Zhao.
Earlier, we actually be obtaining three results from SEM. So from the three results, we can actually find out more about the application. So for a start, we'll talk about secondary electrons. This will actually be the image which we will obtain from it. Okay, so from this image obtained, we can actually carry out morphological investigation. It's something like a quality check, which company which actually manufacturing nanomaterials will use. So for example, a company which manufacture batteries, they will actually use nanotech to enhance their materials property by actually reducing the size of its active materials. We actually have backscatter electron. So this will actually be the image which we obtain from it. Okay, so from this image, we're actually able to carry out compositional contrast, and through it, we're actually able to find out the chemical composition of the material. So what does that do? Okay, actually, since we are able to find out the chemical composition, we'll actually be able to find out contamination from the material. So those in the research industry actually carry out this test a lot because they have to ensure that the materials which they use for their research are actually free from contaminants, so that they actually get the optimal results from their research. Last but not least, we actually have X-ray. So similarly to backscatter electron, it actually enables us to find out about the material's chemical composition. So what's the main difference between the two of them? It's actually that X-ray will enable us to find out about the quantifications in elements, from boron to uranium, which is proton number 5 to 92. So as you can tell, it's actually a pretty wide range of elements. Okay, now we'll take a look at the image produced by the X-ray. Okay, so for X-ray, it can actually also be used in the research industry because of the research industry actually requires high accuracy in material composition. So for example, in the aerospace industry, we can actually use the image obtained from the X-ray to actually enhance the formula of the nanoceramics based on its chemical composition. 4, 3, 2, 1。
Thank you.
笑什么？
我回去自己看。